All right, today's lesson is on trig functions or trigonometric functions. We're going to be taking a look at not only the basics of trig functions, but we're also going to be taking a look at what it means to take this apart and find some values using these trig functions. Okay, so this is the class version. This is trig functions, the class version. Theta and standard position. We recall standard position. Standard position is where we put the angle with the vertex at the origin and the term or the initial side is along the positive x-axis. And so what I'm going to do here is I'm going to go ahead and I'm going to draw myself a line. Let's see. Nope. Give myself a line here, and I'm going to draw theta. It doesn't really matter where my theta is for the purposes of this. Because when I draw theta, what I'm going to do is I'm going to show that it's opened up. And I'll make this theta. Okay? Theta is opened up. We recall that theta is a ray that is moving about the origin along a path counterclockwise for positive and counterclockwise or clockwise is negative. And so what I'm going to do is this. Let's take a look at these actual values. Because when I draw this in and I take a look at this, what is going on here is really I have a triangle, right? And there's a 90-degree angle right here. And so when we use 90-degree angles, we can use trig ratios. And so let me label my point. It doesn't matter what it is. It's a point xy. We go out x and up y. Well, what happens then is I know that this is x and this distance here is y. What does that make? The other side, the hypotenuse. I'm going to label the hypotenuse with an r. Because if we drew it all the way around, it would be the radius of a circle. So that's r. So we've got x, y, and r of the angle theta. I've drawn this right triangle to help us see that when we're using trig ratios, it's going to be the same as when we studied it before with the SOHCAHTOA and all that business. Okay? So make sure you have this diagram down. Because for this next part, this is a chart. I would suggest you go ahead and pause it here. Copy this chart down. This is going to be important because what we're going to do is we're going to end up talking about each of these as a function of the picture that we just drew. So go ahead and pause this and copy this down. Okay, we're back. Sine of theta. The abbreviation is SIN and then theta. What it means is y over r. Because as you will recall, if we look at our angle here, the opposite, because remember, sine is opposite, the opposite side over the hypotenuse. We, of course, are talking about SOHCAHTOA. Whoops. Lost my place. SOHCAHTOA. Sine is opposite over hypotenuse. Well, then the cosine is going to be adjacent over hypotenuse. Or x over r, and the tangent is going to be y over x, or opposite over adjacent. Where did these come from? Let's take a look here. If I say the sine of theta, the sine of theta is equal to the opposite over the hypotenuse. Well, in terms of x, y, and r, what is the opposite? Well, the opposite is y. The hypotenuse is r. That's where we get this ratio. All right? The same for cosine, tangent, etc. So when we look at the cotangent, cotangent goes with tangent. They're partners. That's why they're in the same color. You'll see them here. And so cotangent is the opposite of tangent. And so instead of being opposite over adjacent, it's going to be adjacent over opposite. Secant is going to be the opposite of cosine. it's going to be hypotenuse over adjacent. And so cosecant, which goes with sine, as you'll notice here, we've got these two go together and the outside ones go together. Okay, so we're grouping them like this. So cosecant is going to be hypotenuse over opposite. And of course, remembering that r is our hypotenuse. Okay? Make sure you have this chart down. A good way that I remember it is I use sine to be y over r. It spells SYR or SEER. Okay? So take a minute to go ahead and copy that down. Okay? So we've got these trig ratios that we're using. Now, finding trig ratios. Find the 6 trig ratios for theta if theta is in standard position and the point -2,3 is on the terminal side. Something I would suggest for you to do. Draw a picture. Because when we open up theta, it's going to show us a lot of things. And so what I'm going to do is I'm going to go ahead and mark up these axes. And it's going to be -2,3. Okay? And so that's what I'm dealing with. Instead of doing that, though, keep yours. I'm going to draw mine a little bit bigger for teaching purposes. Okay? So I'm going to go... Okay? And -2,3 is on the terminal side. So I'm going to draw the terminal side. And I'm going to complete this triangle like such. Okay, so this should be 2 right here. All right, so I've got this triangle. Now, go ahead and mark what is actually going on. This side is -2. This side is 3. This side is r. We don't know it. But what we can do is we can find it. So what I'm going to do is I'm going to label out what I already have. X, Y, R equals. This is going to allow me to set up my chart nice and easily. So I've got X, which is -2, Y, which is 3, R I do not know. However, because I know that this is a 90-degree angle here, it's a right triangle, I'm going to use the Pythagorean theorem to say r squared is equal to -2 squared plus 3 squared. Okay, so that's 4 plus 9, 13. So r is equal to the square root of 13. How does this help me? I now have x, y, and r. So what I'm going to do is this. Sine of theta. Remember your chart. Use your chart from your notes. The sine of theta is equal to y over r. The sine of theta is 3 over square root 13. Done. Okay, so right next to it, I'm going to put the cosecant because we remember that they go together. Okay, sine and cosecant go together. So that'll make it easier for me to just switch them and put square root of 13 over 3. The cosine of theta is x over r. So I'm going to use x over r, so -2 over square root of 13. Okay. The secant of theta is the opposite of that, the reciprocal. Okay. Tangent. If you need to keep looking back, keep looking back. I'm doing it for illustration purposes. So tangent is y over x. So y over x is going to give us 3 over -2. And the cotangent of theta is equal to -2 over 3. I've got my 6 trig ratios. Okay? what we should do here is pause a second and say, how did we get that? The first step was to find x, y, and r. The second step was to put them together in the ratios that we already outlined in the previous table. You will get an idea of how this works as you continue to work with this concept. Of note, you'll notice I have square roots. You don't need to rationalize the denominator unless I tell you to. So you can leave the square root of 13 in the denominator unless they tell you to rationalize the denominator. Okay? Now, how else does this happen? They might say the point is on the side, or they might just give you an angle number or an angle measure. And so what we can do with that is we can say, find the sine and the cosine of 45. Well, if we recall, this is 90 degrees up here, right? If this is 0 degrees. So 45 would be halfway in between. So if I go and connect these dots, I've got something like this, right? Well, then I just need to pick a point because I'm going to pick something very convenient. I'm going to pick 1, 1. And so what you can do over here is, instead of doing that, draw your triangle over here, showing you a different way to do this. So I've got 1, 1, and my 90-degree angles here. Well, if I draw this, I know that this is my x. So x equals 1. Struggling. X equals 1. Y also equals 1. And r is going to be 45, 45, 90, 1 times the square root of 2. Okay? So when I come down here, I'm outlining x, y, and r so that I can go like this. Sine theta is equal to y over r, 1 over square root 2. Cosecant of theta is equal to square root of 2. Cosine of theta is equal to x over r. So 1 over square root of 2. Secant of theta is square root of 2. We've got tangent next. But what is our question asking for us? Well, our question is saying find the sine and the cosine of 45. Okay, so we found the sine and cosine right here. You're thinking to yourself, but they're the same. How does this happen? Really, aren't we taking the sine and cosine of 45? And so because they're the same, we know that both of these sides are the same. Does that make sense? Yes, it does, because x and y are both the same in this one. And so our sine and our cosine are going to be 1 over the square root of 2. Okay? Next example. Once again, if you're taking notes on this and you have questions about how this works, take notes in the margins and say, I didn't understand that part. Where did you get this? Why did you do this? Okay. One more time. If you think you can do this one, go ahead and pause it. I would say a hint for you would be to pick a convenient point. So go ahead and pause it if you'd like. I'm going to go ahead and roll through it. If you want to take notes and watch, that's cool too. 270 is our angle this time. What is 270? 270 is down this way. Okay? 270 is down this way. So I'm going to pick a convenient point. Right there. What does my triangle look like? My triangle doesn't look like a triangle. But I can still find x, y, and r. My convenient point would be 0x, negative 1y. So if I'm going to find r, what is my r going to be? Well, let's look. My r is my distance from my origin to the outside. So if x is 0 and y is negative 1, my r is going to be 1 because that's the distance. So 6 trig ratios. Sine theta is y over r, so negative 1 over 1. Cosecant theta is the opposite of that. Same thing. Cosine theta is equal to 0 over 1, x over r, and the secant is 1 over 0. The tangent is going to be negative 1, so y over x, so negative 1 over 0. And the cotangent is equal to 0 over negative 1. Now, notice two things. Number 1, tangent, and number 2, secant. If you'll recall, we cannot divide by 0. So what we would say is secant and tangent are undefined. They're undefined because we cannot divide by 0. So if something is over 0, it has to be undefined. Okay?